On a vast, frozen landscape, a high-tech blanket covers a small patch of ice, 1.5 kilometers thick. Could this reflective sheet stop the world's glaciers from melting and our coastlines from flooding? It's called geoengineering, using radical new technologies and techniques to combat the multiple threats of global warming. To find out if it can work, a special team braves an icy abyss on the frozen edge of Greenland. Glaciers cover just 10% of the Earth's surface. But locked in these thick sheets of ice is 75% of the Earth's fresh water. Global warming has begun to break apart our planet's frozen reservoirs. As the world's ice sheets and glaciers break up and melt, trillions of liters of water released from the ice are raising sea levels and threatening millions of people around the world.
We're in the midst of a climate catastrophe, and glaciers are the epicenter of that problem. Glaciers are melting at an accelerating rate all around the planet, threatening civilization.
Jason Box is a Nobel Prize-winning glaciologist. He thinks the melt can be stopped with a simple but gigantic solution.
I've got a vision that could save the planet. Cover glaciers with reflective material, stopping the melt.
Jason believes his plan can protect the world's glaciers from rising temperatures and the rays of the sun. But the only way to see if his idea works is to test it with an experiment on a real glacier. Jason's asked for assistance from a Discovery Channel team. Billionaire businessman Kevin O'Leary is the team's logistics expert.
Everything I need has to get there onto the glacier.
Jennifer Languel is a leading eco-engineer.
Exhaustion is an understatement.
And physicist Basil Singer is the team's science advisor.
That looks extremely scary.
Glaciers around the planet are decanting into the oceans at shocking rates. I want to stop that, and I've got a vision that I think might work. What I'd like to do is lay out a reflective cover over a couple acres on the surface of a glacier and prove that this technology works.
Can you imagine how difficult it would be to cover a glacier that size?
It's going to be expensive, but when you consider the cost of re-engineering our coastlines, this may actually be cheaper.
The team faces two major challenges. First, Jennifer has to find a material that can reflect sunlight and withstand freezing temperatures. Next, Kevin must get a handle on the logistics and costs of carrying out a plan on this scale. But before he can do that, they'll need to target an ice sheet. And Jason has one he's researched for months. He'll test his strategy on the world's biggest island, Greenland. More than 2 million square kilometers of frozen desolation, caught in the grip of global warming. 85% of Greenland's rocky surface is covered by an ice cap, 3 times the size of France. This immense sheet of ice, an average of 1.5 kilometers thick, is melting faster and faster every year. If Greenland's ice cap were to melt completely, oceans would rise 7 meters, threatening 1 person in 10 around the world. That's why Jason knows it's vital to see if his plan could work here. So he's showing Basil the scale of the problem they're about to tackle.
We're flying over this massive expanse of ice. I've never seen so much ice in my life. 360-degree horizon, everything is ice.
To show Basil just how fast Greenland's ice cap is melting, Jason is searching for a gaping hole in the ice, called a moulin. They're found by following the flow of rivers that form as the glacier melts.
Now we start to see some melt channels forming on the surface. We start to see some water collecting in crevasses.
Then Basil spots it.
That is huge. Loads of water just disappearing down this black hole.
Moulins are created by powerful forces at work in the glacier. As glaciers melt, they move towards the sea. When they slide over irregularities in the bedrock, the motion causes cracks as deep as 50 meters to open up. At the surface, meltwater floods in and forms colossal waterfalls that can plunge as much as 1,500 meters. Jason knows the moulins hold the secret to just how fast a glacier is melting. The flow of water into a moulin represents the speed of melt. The faster the flow, the faster the rate of melting. And to measure the flow, the team will have to go right to the edge. Glaciologist Jason Box and physicist Basil Singer are in Greenland to see if they can save the planet's glaciers. They want to measure just how fast this one is melting.
The moulin is really the epicenter of our concern, because all the water is channeling down into this one point. By measuring the flow rates, we can understand how much water is going into the glacier. Oh, wow. Whoa. Welcome to the epicenter of global warming. It's just bottomless. No light escapes.
Basil has volunteered to take the first reading.
Just walk it back.
Give me attention.
Don't lean towards me, lean back.
That looks extremely scary.
The only way to know how much water is going into the moulin is by sticking our sensors in and making a measurement right there next to a bottomless pit.
The water drops for a whole mile. You would not want to fall down there.
There's no escape from a moulin.
Look off! Look off!
It's just got danger written all over it.
I never thought I'd be standing at the edge of the abyss like this.
I'm so scared.
But the information is so important, we actually have to take that risk.
Let's make these measurements and get out of harm's way.
They use a flow meter to measure the water's speed.
Let's see how fast the water's dumping into this hole.
Okay, so we're measuring the flow rate now.
Dab it in there.
Whoa, that's so strong. Look at that, whoa!
There's so much energy here. That's the force of this water. What's the speed?
That peaked at 9.4 miles an hour.
That's really moving. This must be about 1,000 cubic feet per second. This is more melt than I was expecting.
On a scale from 0 to 10, how serious is this melt issue?
It's an 11.
In just one day, nearly 42 million liters of fresh water drain down this one moulin alone. And Jason believes there are hundreds, possibly thousands more of them on the Greenland ice cap. The data sends a chill up Basil's spine, and it's not from the cold. At this rate of melting, Greenland is losing enough water each year to cover Germany a meter deep. Glaciers are colossal rivers of ice moving downhill towards the sea. Ironically, these immense flows began with nature's most delicate form of water: snowflakes. In cold regions, not all the snow melts in the summer. Year after year, these snow layers stack up. The weight of the snowpack then compresses them into thick ice, solid rivers that can reshape continents. Now, global warming is consuming Greenland's titanic shield of ice. Scientists now calculate the glaciers of Greenland are moving towards the sea 3 times faster than a decade ago. At stake are coastal regions around the world.